Here we demonstrate Newton's first law of motion. An object at rest will stay at rest unless propelled by an outside force. The same is true for an object in motion, as demonstrated by this push.
This free body diagram demonstrates an object at rest where gravitational force and normal force are equivalent and there is no applied force or frictional force. This free body diagram represents an object in motion where frictional force is less than the applied force, but gravitational force and normal force are equivalent.
Go. Go.
To find the net force in the object, you take the equation F net equals mass times acceleration. You are going to find the net force of a vertex arrow howler football being thrown at a short distance. First, we would draw a simple diagram of what is happening. So you have the football being thrown. So we have the net force, which we do not know, and we would have the mass and the acceleration. First, to figure this out, we would write what we know. In this situation, we would know the mass, we would know the acceleration, and then we would write what we don't know, which is the F net. We see the variables F net, mass, and acceleration, so we know that we use the equation F net equals mass times acceleration. This formula helps us explain Newton's second law of motion.
The pogo stick pushes on the ground, and the ground pushes back. This is Newton's third law of motion in act. We're going to show the top spinners and how the third law affects them.
Go.
We're going to show these tops and how they interfere with the third law.